Okay, I think we're up. Audio check. 1, 2, 3. I could hear that, so. Pardon me. Okay. All better. Now, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. Today, we are starting work on the last of the doodads. In this one, we are going to put seeds in dirt and make it rain and sunshine on them to make them grow. That's the plan. This is an old Emacs buffer though, so let's just start fresh. That's all stuff from the compiler stream Friday, which was unfortunate because we found a bug, and we're refreshing our memory on how we were doing things so that we can try to debug that. We'll finish that up this Friday though. Okay, journal. To do. Okay, so last time we finished up the last of the space doodad. Today, or let's see here, after hours, I moved two images, the ping and the archer, into a scene elements one, and that saves me 4.5 megabytes. I did clean up the wave animation on the archer, the space, there was a bunch of too much alpha, the rings didn't look good, so just did some art cleanup, basically art only stuff. And then I started on the art for the plant doodad. It's not been integrated at all. It's just in a file ready for us to start using. So we are ready to start streaming work for week 25. And here we go. Tasks and notes. So today we're going to do this one. Add lots of dirt. Add envelope for seeds. Add cloud. Add sun. Click cloud or sun to wet or dry dirt. Click envelope to plant seeds in pot. It's your rain sun cycle to grow the plants. I think that's it. That's the rough outline. Hey, G Finelli. How are we doing? We're doing good. We're just planning out the work for the day. Did a bunch of artwork after stream, so hopefully we can just go straight into the coding and not have too much to fix up on the art side. Yeah, pretty good weekend, pretty relaxing. Went and did a little singing in a Christmas choir. It's kind of fun. The Holly and the Ivy with the handbell chorus, actually, it was kind of fun. How are you doing? How are you doing? How was your weekend? I'm trying to play around with the renderer. Yep. Um, that's one of the reasons I limited myself to OpenGL 3.3, and I think I only allowed myself 8 shaders. So vertex and fragment shader. I only allowed myself 4 shader programs, I guess. So yeah, I knew I would play around with it too much and not get the game done. Next game, we'll do something more interesting and challenging. But for today, we're doing simple stuff. Still not sure about the terminology. It always gets me confused and didn't work yet. Yeah, I find a lot of online resources assume a certain amount of knowledge before, and nobody, or at least I haven't found that many that break it down well and give you that vocabulary gap. Um, it is kind of its own special little language. Well, let me know what's confusing you. I'm not a render expert by any means, but maybe I can point you in the right direction. Or I'll just sit here and say, I don't know. That's possible too. Okay, I think we're ready to start off. For example, I know that a pipeline is where shaders are, and a shader is how to deal with data you pass it. Okay, all right. So a pipeline is a sequence of stages that happen in order. I don't remember which render engine you're using, but for example, in OpenGL, it's less this way, but it used to be a very fixed pipeline, meaning OpenGL always processed things in a very specific order, in a very specific way, and you would put your things in the different stages. So, for example, your shader exists in 2 different pieces, and one of them is the vertex shader, and one of them is the fragment shader. And there's other shaders, so we're not going to worry about those right now. The vertex shader says, here's my geometry and how it fits in the scene and how that maps to the screen. It doesn't actually draw anything, it just does math to figure out which pixels in the screen are we talking about. So when you say, here's a triangle, it does the math and says, here are the pixels that matter, and then those pixels are handed to the fragment shader. And the fragment shader takes each pixel, and it's actually more complicated than that, but for now, 1 pixel equals a fragment is good enough. It takes each pixel and says, for this pixel, what color is this pixel? So that's where you have your colors and your texture sampling, and it says, wherever this pixel is, here's the color that goes with it, and it sets that to the screen. But a pipeline is a lot more than that. For example, the pipeline also maintains your data, right? So you'll pass a whole bunch of textures, vertex buffer data to your pipeline, and that all is used at different stages, and then is passed into your shader programs. Yep. Well, buffers have to be in memory for the pipeline to access them. So yeah, the buffers are part of that pipeline. The pipeline is just, here's where I look, here's what I do with it, and here's where I look for the next piece. So if you give instructions to the pipeline, but you don't have a buffer defined that it can access, it's going to break. So I kind of get that. What I don't get is how to structure the execution. Yeah, so I'm using OpenGL. If I remember right, you were using WGL or something like that. WebSDL, something like that. So most of the time, like who should keep the buffers, who should keep the pipeline, what do I call those, in what order? Okay. So in our case, here, renderer, draw. So when I call draw, that's where I say, here's my vertex array, here's my index buffer, and here's the shader. And it binds the shader, binds the vertex buffer, binds the index buffer, and then makes the call to OpenGL to do the draw, right? So that's like at the heart of my render engine. Then it's actually inside the application that things are started, right? So if I go in here and I say on render, or let's see here, renderer initialize scene manager scene render. So the application says call everybody's update function, then call the render function, and this goes through each scene and calls its render. I guess let's see here. Where is it? And it computes the view protection matrix. Then it calls on render for the scene, and each scene. So for example, let's see your game scene has an on render. And then I call the actual objects render for each object. So if we go to like chalkboard, let's see, maybe there's something more interesting. Well, the chalkboard is just a textured quad. So the textured quad defines its render, and it says find my shader, pass in the UV values, the uniform values. Then it calls draw with the vertex buffer that the object stores and its own index buffer which it stores, and what shader. And this all goes into that render call in the renderer. Does that make sense? So your application tells the scene to draw at some point in the event loop. The scene then goes to each object inside of it and says, hey, you draw yourself. And then each object knows to pass to the renderer the vertex array, the index buffer, and the texture shader. But you have to bind your values first. The texture shader has to be bound. The shader has to be bound. The where's my texture? Where's the texture? Oh, the texture has to be bound. You have to set your uniforms, etc. Web GPU. Yeah. Yeah, so this is an example of who keeps some of those buffers. In this case, yes. Now, how you define your objects can be different, right? So if you're doing a particle system, each particle doesn't maintain these pieces of information. Rather, each particle is like an offset into a couple of different dimensions to move the thing around, but it only really has probably one vertex buffer and one index buffer. Because each particle is identical, you just change the offset. But things like that. Yep. So in this case, that's how I divided it up here. But there's a million different ways you can slice and dice. I don't know if that helps. Like I said, for buffer sharing and whatnot, that you can get some very clever things going on, but we're just keeping things simple here. Each texture I want to draw on the screen has its own buffers. Yeah, so the scene's job is to maintain your camera for your screen projection transformations. So the scene has the camera, and the scene has all the objects that are in the scene, right? It manages those. So when you call draw, they all get done. Okay. So for me, so questions about sprites. If I have something like a sprite, do I have a sprite pipeline, index and vertex buffers for sprite? And I should just call draw with the transformation matrix and index, right? Camera, for example, is a uniform buffer, correct? That we pass to all pipelines. So what I do for that, let's see, texture quad. There it is. So when I call the shader to render a textured quad, I say set this 4x4 floating point matrix to the view projection matrix of the camera times this object's world transform. That's just the way I do it. There are some variations and whatnot, but this is basically it. So yeah, I set the uniform for here's the model view projection matrix, and here's the actual value. So that's one thing. For a sprite, what I did, and this, again, may not be the right way to do it, because there's different ways to do it, is the sprite, it's just a texture quad. All the class of the sprite wrapped around it has to do with keeping track of a timer, and when that timer triggers, changing the frame index. And when I set a frame index, what I'm really doing is it's a wrapper that says get the next UV coordinates and set those in the texture quad. So I'm still setting the same texture. There's one texture with a whole bunch of frames inside of it. And I have an array of, here are the UV coordinates for this frame. Everything in Sprite is just a timer that updates the UVs on the texture quad. So my Sprite is really just a UV texture quad. But it uses the same exact pipeline as the texture quad. That's it. And this is not the only way to do it, obviously. You could bind each sprite frame as a separate image. And then yeah, you could just bind literally the index of the image in the image array. Quite confusing, not gonna lie. Yeah, no, the Cherno videos were enough to get me started. I don't know if I already shared that link with you, but he's in OpenGL, which may not be as helpful to you. So for me, here's all the shaders we use. Assets, shaders. So I have a textured quad. I have a colored quad, so you can just say here are 4 coordinates and make it this color. Then I have my text renderer, and then I have texture batch. So textured quad batch. So I can have multiple quads and just one texture, or multiple textures and a bunch of quads, and it'll draw them all in one shot. So this lets me batch up a whole bunch of stuff and draw in one draw call. But you really don't need that to start. Like if you just have this and this to get started, if you just have a texture quad and a colored quad, you can do a lot with that. I did need the batch drawing, and I do need to render text, but that's it. I've got four shader programs basically. Each shader is for a pipeline, correct? Nope, the whole pipeline, I don't do anything to specialize the pipeline at all. It's all very generic pipeline. So the pipeline is fixed. It says load up your stuff into a buffer. And then when you say draw, what it does is it says, I'm going to go to the vertex shader program, and I'm going to do math. based on these buffers you sent me. Then I'm going to pass the output of that to the fragment shader to determine what colors get which pixels get which colors. That's kind of the simplified pipeline view. There's a ton of other stuff it can do, but we're not using any of that. So then each draw call we make just takes those buffers, puts it in, and says, put this stuff on the screen. So the pipeline is pretty simple in our case. So in our case, the whole pipeline is a fixed pipeline. We're ignoring all the specializations we can do in the pipeline. It's put in data, fragment shader, or vertex shader, fragment shader, and then that's your output to the screen. Yeah, WGPU is the difference. That's why I'm like, I don't know about you specifically. Mm-hmm. Mm-hmm. So each shader is in a unique pipeline, huh? Interesting. Sure, you can ask if you want. I can't promise I'll have an answer for you. I'm not much of an expert in game development or render engines. But I'm always happy to try. You take a look at the code, even if you don't understand Rust and GPU. I can give you some points to look at. You might say, oh, you could do this. Yeah, you have like a GitHub or something, or there's the programming channel on my Discord server. Either of those would work for me. At least in the order of creation aspect of things, right? I can look. I might not be that helpful, but we'll see. There are no guarantees. Okay. So I assume it's in the render. Oh, so are you doing... Okay. So GPU context is your surface, your device. Okay. Don't see anything too weird there yet. A vertex has a position and a UV. Okay. A vertex. Fine. Okay. Description. Okay. Sprite pipeline. New device. Find group layout. Shader module. Vertex state. Fragment state. Okay. Create pipeline layout. Create render pipeline. Okay. Brings us to the renderer. Get the current texture on the surface. Texture, create view, encoder. Which you told us the encoding of. Pre-present notify output dot present. Okay. Okay. Basically have an ECS that would do everything to set the data, and at the end of the stage, it should have a system to deal with that data and pass it to the renderer. Now I have a problem on how to structure the renderer itself, not the data to be passed to it. So El Psi Kangaroo, that was AK Elements. He's dropped into the chat a few times, but yeah, he does IMGUI notification stuff with Toast, I believe. Yep, AK Elements. Yeah, he's working on his own game engine called Onyx. Pretty cool. He's got a lot of experience in actual game development, so he's a good one to talk to. I don't know if he's streaming right now. Okay. Okay, so hey, Pat, long time no see. How are you doing? Yeah, AK Elements is when you're looking for El Psi Kangaroo. G Finelli. Okay, so we were looking at your renderer. My guess, without knowing much Rust or Web GPU, and probably I don't have all the latest. So for example, in the render shaders, it's empty. So I'm assuming that I'm just out of date. I suspect you're close, and you're just missing a couple of steps, like to make the connections between the objects and their data into the pipeline. So what I would guess, Chief and Elliot, you should do is find a minimal example to get a texture on the screen with WGPU, and just copy that and just get something to show on the screen. Once you have something on the screen, then you can play with the system and try to like tweak it to pull your data in. Because I think you're close. It looks like you have a lot of the pieces you need, but you need to find a minimal example of Rust web GPU and just get that minimal example working, even if it's a separate application, like you're not building it for inside of the current, but it'll show you all the pieces in the recipe. Trying to life. Yeah, life is hard. It sure can be. So I guess the good question is, how do I go over all the entities, get the normal data, and now what? Get a pipeline that's based on those entities, set buffers, and pass to the underpass. Not knowing much about how web GPU pipelines work, my guess is each object is going to maintain a reference to one of your pipelines. You have a triangle, okay, that's good. So each object will maintain a reference to a pipeline and shove its data into the pipeline. So I would say what you want is you want an application that runs your event loop. You want a scene that maintains the objects you want to render and interact with. And the scene should, inside the event loop, update the objects and then call the render. Then each object has its vertex buffer data and colors and textures and whatever else. And it's going to have a reference to a pipeline. And it's going to say, hey, pipeline, when somebody says render, here's what I mean. I mean, take this data, shove it into the pipeline, and go. It's probably something like that. So you'll have a limited number of pipelines. It sounds like web GPU creates a pipeline per shader program. So hopefully that helps. I don't know. It is confusing. Like and this is OpenGL. Let me see if I can find it real quick for you. This is basically what I started with, and then I built my game engine on top of it. So it's here. It's basically this guy, and it was this playlist, this one. Okay. So I watched this guy's intro to OpenGL, and I just followed it until I understood enough of the pieces to build my own, still largely following on that same foundation. But if you can find a series like that for web GPU, that's probably the way you want to start. Like web GPU with Rust. That's not going to be helpful. I prefer YouTube videos because then I can just sort of follow along and pause and rewind and rewatch things as I need to. Okay, this takes forever. Because some of it's the same, like clear colors and surfaces and textures. Oh, pardon me. So like maybe this playlist, or maybe this guy doesn't have it in Rust. I haven't looked that closely at it. Copy. Maybe this doesn't have it in Rust. Oh, are they that much different? Yeah. So the second to last link I put in the chat should be Rust and web GPU. The next one is web GPU, not necessarily Rust. I don't know. I didn't look. Oh, I think he is losing Rust. I think both of those playlists are Rust. So I'd say just watch the videos. Like, that's pretty much what I did. I have so many tabs. Yeah, I know how that goes. I've got too many tabs open too. It's a problem. Yeah, so I think those two playlists ought to get you a good start on it. Oh, they weren't that helpful? Hmm. That's unfortunate. Hmm. Biggest is a problem is code structure. All these are single files. Oh, okay. I see. I can draw a texture and work in a single file structure. Okay. So if it's a structure problem, you have an event loop, which calls the scene update. I mean, it does other things, right? Maybe time, user input, etc., etc. You know, whatever else you need. The update and the render. So for each object.render. What the object is going to do is it's going to have is the pipeline. Let's see here. ECS, yeah. I learned Python to an intermediate level about 5 years ago. I wrote a few hundred scripts for network changes. Going back through Python now, but really questioning if it's even worthwhile anymore considering AI. I would not plan my future based on AI. What the current round of AI is, I don't think can replace humans unless your job is really boring. Um, Even then, it shouldn't replace those jobs. I think it's a fad. I think it's going to fade off here unless they have a completely different breakout, change, update. Um, I'd say any skills you learn are worthwhile whether you use it professionally or not. So for myself, I say people should learn, if they want to be a good programmer, they should learn C because it requires you understand what the machine is doing with your memory and how things work. And then you should learn Lisp because then you understand programs and abstract syntax trees and that the program is just data and recursion. It teaches you a bunch of ways to think. Now, whether you use C or Lisp doesn't matter. It's learning to think. So if you go back and relearn Python as your way of getting into programming, I think it's a valuable skill regardless of AI or whether you even use Python itself. Okay, so gfinelli, my entities will store a sprite and handle to a texture. Okay, and transform position. Yep. Now that I need a system to prepare the pipeline and buffers. So I guess I don't know enough about the web GPU pipeline. I tried to ask ChatGPT and it kind of, yeah. So each object has position, size, so in other words, geometry, right? Geometry of the thing. It has the texture. I think it needs a reference to a pipeline. And then each object in the .render find textures, past uniforms. So let's see here. Web GPU pipeline. Let's see. Vertex, fragment, blah, blah, blah. We know about those. WGSL, writing the shaders. So blah, blah, blah. I guess what I'm more curious about is what does this prepare how do we use the shaders? Blah blah blah. I'm just scanning through something, anything, primitive state. We saw that. Depth stencil. Okay. Render pass. Set pipeline render pass draw. I'm looking at these two lines as being inside of an example here. Set pipeline and draw. It looks to me like the object set pipeline and the dot draw. So we'll see, does that expand on that much? In render. And that's setting a pipeline and how many vertices there are. Okay. Set in uniforms. I don't know. Uniforms is the same word in WGU. And then I'm going to learn eventually that the scratch buffer is not like other buffers. Okay. Call the draw. So per object, you set the pipeline. So each object, depending on what kind of object it is, probably has a reference to one pipeline. Set uniforms. Pass buffers. Vertex index buffers. So let me see, back to your code. So your main application, it's a window, application handler, blah, 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 event loop. Okay, so you have your event loop. App window request redraw. Okay. Request redraw. Okay. So your app, super great. Scene, fixed update, exit. Scene for menu, application, window event. Okay. Let's see. Scene manager update. Scenes. Change process, fixed update. So where is the render being called at the top level? I see update functions in your scene. Current scene. Scene manager, okay. Context. Input. Box new scene. Yeah, I'm not sure. It's after scene.update. Is that all on the main branch? I don't see. I think you might not have pushed recently. Maybe you have some uncommitted code. Render system should be where I prepare everything to be rendered. Shouldn't really be tied to the scene because all the scenes render at some point. Yes, inside the window. Okay. Right, so in your renderer, render self. Okay, so what I would say is probably render system. Okay. Okay. Oh, there it is. Yeah, use create render system. I see. Okay. Darn Rust. I just don't find it as readable. Okay. So what I would say is probably your initialize your application. I would say probably what needs to happen is your renderer initializes pipelines. And then when the scene store a reference to a pipeline from renderer, something like that. It's depending on what kind of object it is, it knows which pipeline to tell the renderer to use. Color attachments. Yeah, so you're hard coding a color here. You're not even doing texture work yet. So this is, so what I would say is probably start with what you have in renderer now and pull out some things that you can. So right now render renders itself, right? It can only have data from within. So let's say we have pub fun render mutable self, right? Put a comma and then say color, right? Just pass the color in, and then render that. Okay, then where's your vertices? Wherever your vertices are stored, pass that in as well, right? So when you say render vertices and the color, or pass in the vertex data, and then call render. Then you can have two calls to render, one that renders the blue one somewhere and one that renders a red one somewhere else. That starts to pull the data outside of the render call and get it passed in. For me, I let the type of shader define each pipeline, like a shader specification, then the pipelines use the shader. Yeah. Basically, all entities that have a sprite will use the sprite shader, so the sprite pipeline. They aren't stored at the moment. So for now, just put it inside your main. Like pull the data outside of this render call and just put it in main. Like do 2 calls to render, but pass in the color and pass in the vertices. Or I guess the vertices are contain the color data, right? Is that, let's see, render shaders, not shaders, render vertex. Your vertex has a position and a UV. Just add a field to that called color and just pass in the vertices to be rendered. Does that make sense? With different positions and different vertex, step mode, vertex, flip 32 by 2, flip 32 by 2. Okay. So, let's see here. So vertex, okay. I know color's not that important. I'm just saying to get to the next thing. So what you want to do then is create probably an object, which we'll just call color quad. And it's going to have 4 vertices. Each one will have X, Y color. And then you probably need 6 indices to describe 2 triangles. I don't know exactly how Web GPU does it, right? But then, instead of render doing what it's doing, render. Instead of it doing this, let's see, the object needs those things. It also needs renderer pipeline reference. You know, and however you get that, whether it's like a enumeration or an actual, you know, pointer to or something, it doesn't matter too much. But then instead of this, do, and what's immutable? I don't remember. Does it matter? Color quad. Then somewhere in here, set pipeline pass. Let's see, where is? And I just don't know enough about this. Begin render pass descriptor. There's your clear. Where's this? Are you not? Where are your actual pass draw? 0 to 3, 0 to 1. My guess is these 3 lines yeah, I'm not sure. I don't know enough about Web GPU, I'm afraid. Let's see. Well, color can be important with textures because you can always multiply a texture by a color, but that's fine. 4 vertices, 6 indices. Yeah, so instead of color, it could be texture. It kind of doesn't matter. What you mostly need, you know, texture. Well, in which case, yeah, texture reference and UVs. Sure. To finish the encoder. But the encoder encodes 1 draw call, is that correct? Let's see, else I use a batch renderer, store the data in a struct called the draw call buffer, which holds an array size. I then apply the texture and other uniforms relevant for that draw call. I don't think the order matters. Not when you bind, usually. As long as everything is available by the time you make the draw call. Okay. Each draw call buffer is identified by a hash of the shader spec. Yeah, so this sounds like it's 1 draw call. Set texture, vertices, indices, lookup pipeline. Dot, dot, dot. All that stuff. Yeah, if you can just pull this data out of wherever it is and put it inside of a thing, then pass that thing in and do the bind and the set of all those parameters. I think you're close. 6 indices for 2 triangles. Texture quad, whatever. Yeah, I think he's mostly in the implementation details of how to abstract the piece that he wants. Is what it sounds like. He can draw a triangle. I think he's close, just needs to pull out that layer of abstraction. So basically, if you can pull the vertex and texture specific stuff into an object and get that to render, then you should be able to make 2 objects and just change the values in one of them. And then you'll have 2 different textures, 2 different things drawn, right? Because honestly, this is basically it. That's all you need to draw a thing on the screen. And it doesn't have to be a quad, but I prefer quads because most of my images are actually rectangular. Okay, so we're gonna need some texture quads. We could even cheat. All right, you're heading out. Hope it's a good stream. Thanks. Good luck to you too. Texture quad batch. Pots and dirt. They're not going to do anything. Okay, let's set up. Maximum number of children. We're going to start with 1 and we'll see where we go from there. No, we need 2, 3, 4, 5, 6. Oh, let's just start with 12. Whatever. Pots. is going to be 6 different texture quads, all in a single draw call. Okay, sorry about that. Yeah, no worries. Like, my energy ran out. No worries. Basically, the things that you want to change between draws is what you need to pull out of wherever you're manually doing it, right? And put them into an object somewhere. Then object calls the renderer with the rect parameters. So you have to be able to pass in stuff. And maybe it's not this object, maybe it's the actual object, which is fine, or maybe it's the vert buffer, frag buffer, and the texture. I don't know. You can do it several ways, but basically you want to pass in the stuff that you would normally, that is right now hard-coded. I guess the only difference from web GPU and OpenGL, no, I have to create the buffers before I can use them. So let me go do that, show you that real quick. So in my texture quad, when I initialize the texture quad, I initialize a whole bunch of buffers. So here's the index buffer, here's the texture shader, so I create that, which in your case is not the case because you'll use a pipeline that already defines that. And then I say, here's the shape of my vertex buffer. It comes in X, Y, UV, and a texture slot for me. So I set all that up, and that looks like, let's see here, where's my vertex buffer? Vertex buffer. Whenever I create one, it does a whole bunch of OpenGL calls to set it up. And here's, tear down, and I do have to call bind. So there's a whole bunch of OpenGL stuff that I've abstracted away. I assume they're similar for web GPU. Then an index buffer for me, I have to create that. That creates the buffer in OpenGL before I can use it. Then when I want to use it, I call bind on it. Right? I tell the GPU, hey, I need you to give me a buffer, and then I say, here's how big it's going to be, that sort of thing. I don't reuse the same buffer for similar quads. Let's see here. Should I store those buffers in the same struct as the pipeline? I would say no. I see that you set the data for each entity that has a quad. Yeah, so in texture quad, I get my vertex buffer, and then in this case, well, it doesn't matter. Here's the UVs. I set the UVs up early. I set the texture slot, my index buffer, my texture, my shader. So in this case, there are some things that I can reuse in texture quad because every texture quad has the same index layout and the same shader. Those are shared among all the different text quad instances, and the buffer layout doesn't change between texture quads. They're all the same. Then I create my vertex array given the buffer and the layout. Blah, blah, blah. Let's see, set texture. And then when I render, all I do is find my shader, find my texture, find my, model view projection matrix, any colors or things. Then I call draw. Each entity player holds the vertex buffer, index buffer, texture buffer for it. That is the easiest way to start. Each object contains everything it needs for itself. Later on, you can optimize based on, are these actually the same or not? So, for example, the index buffer for all single quads is probably the same. And you should be careful, like decide which one is vertex 0 if you want to do that. And then, so for me, I decided, and this is for vertex and indexes and everything I do, I decided that I would always lay out my vertices this way. This is vertex 0. This is vertex 1. For me, it's vertex 2 and vertex 3. So basically, I start at the upper left-hand corner and I march around in clockwise order. But you don't have to. You can. But then when I set my UVs, this is the order they're in. When I set my vertex positions, they're in this order. But I'm at least consistent. Once you've decided on consistency, it's fine. You can do whatever you want. But yeah, I say each object probably contains its own buffer data. How to make things work, it's easier to just make a quad component that holds vertex and index buffer. Yep, exactly. And like I said, there's a million ways to slice and dice your data. But it's just, the first step is to just pull that data out of the actual render call. Right now it's all very hard-coded. So just pull out the few things you want, put them into some abstraction somewhere, and make that work. Yeah. If you choose the right abstractions at the right times, it does make things a lot easier. But like I said, there's so many different ways to do it. There's no way that they could make those decisions for you. Because your data, it's yours. You know what its shape is. You know how it has to behave. Yeah. Where was I? Pots. We were doing pots. I guess I could also have an interlaced array of entities and pass that later. Meaning my render system just gets information and aggregates to an array. Let's see here. What game are you working on right now? Like, how many entities do you think you'll have? About 500? Okay. Then in that case, I wouldn't actually worry that much about optimizing anything right now. 500 draw calls is not that many. Don't pre-optimize until you know how the system works. So if you just say literally every single object is a sprite, every sprite has a vertex buffer, index buffer, and a texture, and there's only one shader, that's fine. Like, that's a great place to start. Then as you get comfortable with what web GPU requires, then you start getting clever. But at 500 draw calls, I would not be too worried about optimizations like aggregating draws into an array. Don't overcomplicate too early. We'll always have max of 8 characters, the rest is just immovable sprites. Oh, and especially if they're static sprites, then that's not a problem. Okay, yeah. Sounds good. All right, we need these functions here. Okay. Enabled equals false. True. And false. Start off super simple. Update is going to do nothing. Render. If we're enabled, we'll start off with m_pots dot render. Given the view projection matrix. Set bounds. I guess I'm trying to fix things that aren't a real problem at the moment. Yep. I mean, so what you've suggested is, you know, pre-gathering a whole bunch of render data. That's not a bad idea in large systems, but for a small system, it's overkill. It's too early. It's not yet. Keep it in the back of your mind that you'll want to do this eventually, and maybe you create a function in between, right? Maybe you create a simple path through where you say, hey, render this, and then you say, you know, here's another function called you know, dispatch render or something. And that dispatch render might do exactly what you're talking about, or it might just pass it straight through. And for now, you just pass it straight through and don't do the clever thing. But you create that one little place where you can easily insert something into the render, your render processing. Does that make sense? Yeah, don't add abstractions until you need them. Even if they're probably right in the long run for a larger system. Bounds. I actually don't need much in the way of bounds other than the layout. So which is what's going to happen. So let's see. Let's do this. The elements. M_pots dot set quad rectangle is a thing we'll have to do. Set quad texture. I'll do 3 layers for now. Background, yep, entities and floor UI. I will get all the data for those in each layer and just pass it to render. Yep, sounds good. Funny enough, this game will not have collision or physics because it's a turn-based system. I know what hits what at all times. Yep, perfect. Anytime you can eliminate physics from a simple game, that's great. Cool. Sounds like good. Sounds great. Okay, set. So we can do this. I want set quad UV. These are 2 things we want to do. All right, image warehouse asset. Actually, let's just get the texture. Texture equals image. No. Texture store get image warehouse asset background and doodads. Then we get the UV, which is in our case image. Let's see here, UV pot, image warehouse, UV key. What did I call it? Play pot. We'll get the UV for the dirt. to be called pot dirt. Index less than 3 plus index. Then for 4 to 6, 3 to 5, 0, 1, 2, 3, 4, 5, 6. UV pot. Okay. Set bounds. Index less than 3 plus indexes are 3 pots. What we want is an X and a Y and a space. Also, sorry for taking a lot of time today. No worries. I just wish I knew more about everything. Web GPU, Vulkan, SDL, all of it, but I just don't. But yeah, learning to think through the system is a valuable skill, and that was the last of my alcoholics. So that's very sad. Very sad. Okay. X equals. Let's get the archer. Archer dot cpp set bounds. We're gonna do that. Pots dot set flipping entity this. It kind of doesn't matter, but it's fine. X equals rectangle dot width minus, and we want a spacing, so spacing renderer scale 20. It doesn't matter yet. We'll lay things out later. You need pot width. Inventory house. Get UV size. Pot width, pot height. And then we're going to scale those. So pot width equals renderer scale pot width. Height. So we're going to put all the pots over on the lower right-hand corner. So we're going to go right edge of the rectangle minus the spacing for the pots and the pot width. There's X and the Y. So Y rectangle height minus pot height. So X, Y width, not height. Dot rectangle. Then dot rectangle dot x minus equals this much. What do you think? Is that close? It's quite fun, to be honest. It's not that hard. I will always think that the hardest part is the abstractions that need to exist to pass the data around. Yep. Well, and that's basically system design, right? What information is associated or visible to other pieces of the system? And it's make changes to that all the time. You'll make something, you'll be like, oh, that's clever, and then you'll find out later, oh, that's why I shouldn't have done it that way. And then you'll go change it and you'll refactor. But that's just part of it. It's the iteration of what abstractions do I need, which ones don't I need, which ones have a cost, and is it worth that cost to make that abstraction? That's where the craft of programming happens, right? Yeah, great fun. Okay. So in theory, we're setting things at least at the most basic levels. So let's add this to our build system. Plants. Okay. And then game scene. Let's just get this plumbed in here. Like, for example, in this system, I should do more clever things with I can't ever build the way I'm doing things a level editor, but this game doesn't have levels or level editing, so it's pointless for me to abstract things in that way. Whereas the next game I build definitely will have a map editor, and so I'll have to be able to dynamically add and remove things from the scene, and that's going to be a different battle of different battle. Okay. In context, needs to know about plants. There it is. Instead of space, we do plants. Okay, I think we've got enough stuff to run this build. Yeah. And there's only one way to get that kind of experience, right? And that's doing it. You build a lot of bad systems and then you make them better. It's one of the problems I have with modern computer science education is you don't do a lot of big projects, right? I mean, maybe you do a semester-long project, which is a few hundred lines of code, maybe 1,000, maybe a couple thousand total. Like until you're building systems of 20,000 lines or more, and I know lines of code is a terrible metric, but find me a better one. Until you've built a project of moderate size, you don't have to. You can brute force almost everything, or follow just the one trick they're trying to get you to use. Here, use a quicksort algorithm. It's like, well, great, but that's not really the hard part of a system design, knowing that quicksort exists. Always theory, nothing good enough. Yeah, yeah. And there's a practicality to programming that needs to happen. So, what on earth? Okay, we don't have the type. That's fair. Okay, so we're getting there. Doodad chop plants. We'll use texture quads. But that thing failed to copy that into here. All right. I'd say last year should be a whole complex project. That's what I thought, but so they broke my last year into two parts. One was individual project, was one semester, so half of the year, and then the other half of the year was a group project. And the solo project was so easy, I had it done in 2 weeks. Like it was supposed to take a semester long, and I was like, I'm done. I averaged 2 hours a week on that project because it's so simple. Like the teacher had no concept of what would be a good scale project. But I also think that for most students it was the right scale, so that sucks. Probably the best class I had was compilers, because over the course of an entire semester we built a compiler, and that was big and complicated. It wasn't a good one, but I sort of think I made one that helped me a lot. Yeah, exactly. That was after that. Facing down senior design project was not scary at all. I kind of wonder if it would be better if we taught kids, here, you're going to write your own virtual machine for a register-based process, right? Oh no. I mean, that's fine. Actually, that doesn't matter. We're good. Like, I think we should say, here's how you build a register-based virtual machine, which simulates a CPU and memory, right? Then they would be like, oh, here are the parts of the machine. Here's how they interact. Here's why they work that way. Here's what they mean by opcodes. Here's a fake, simplified, assembly language, just to get them over that hump. Then you're like, oh, now we got to build programs with this crappy assembly language. Then we're going to build a compiler that compiles to this assembly language. Then we're going to optimize the CPU. Then we're going to optimize our compiler. And like by the end of 2 years, those students would have tens of thousands of lines of code that all work together efficiently, and they understand why, because they built it wrong, they built it bad, they made it work, then they built it better, then they made something better, and they have a whole vertical stack that they've built and understand in depth. I think that would be a much better series of classes to start with. I would not mind writing that course and teaching it. That would be fun. But so what are the odds my art just shows up? I doubt it. / we've not had great history. Builds, debug. Did it run the right one? So if anyone watching is from my old alma mater, I'm open to taking a full-time professorial position to teach. Hey, we've got it. We just didn't set the textures right. Or the UVs right. Something's wrong. Cool. That is actually not far off where I wanted to be. Maybe a little bit less spacing. In this case, I know exactly what's going on here. Scale, let's just go to 10. We didn't do that. Okay. That should fix a couple of our issues. Not bad, not bad. Problem is, professors, one, don't want to do it, and two, they also don't know how to do it most of the time. Yeah. I had probably 2 good professors, and they both worked professionally for a number of years before going professor. And one of them was my compiler's teacher. He actually knew what he was doing. And then the other one was basically taught a whole bunch of programming classes. And he actually knew what he was doing. But everybody else, like, they went straight from PhD to professor. And it was not good for them. Like, you could tell they struggled to make meaningful sized programs. Hey, that's close but not right. It looks like 2 of these dirts overlapped each other. The pot is not at the right height. So that's awkward. Cool. So what am I doing wrong then with plans? Yeah, most of the professors didn't know what they were talking about. Two times the x plus 0, 2 times the x plus 1. Hum. Oh, I see. I see. I have a mismatch. One professor of mine made us program in a Lisp-like language that I forgot the name of, like Scheme, maybe? It was so old and bad he did not know the language at all. In the end, almost everyone would fail the project he assigned because there wasn't anything to go on. Yeah. I, for some miracle, found out how to do the things and found a bug in the language that was making things not work for everyone. Nice. And you had to teach the teacher about it. Yeah, no, I had a professor. We had to do a program in Perl, which I hate Perl as a language. It's but then on the test, we had to write a function in Perl that would do a thing. So I wrote it out, and he marked it as wrong. And I was like, what? So I typed it into my computer, and sure enough, my program ran. And so I brought it up to him. I was like, "So this works?" And he's like, "Oh, oh, it does. Okay, well, here's your points back." But like, he didn't know the language well enough to know that what I did was correct, even though he wrote everything on the board that I needed, like that I used. I was a little bit mad. But yeah, he didn't even know Perl enough to teach it, or yeah, ugh. And that teacher got into an argument with a student because the teacher said that the TCP networking protocol did not operate at the OSI and TCP layer of the networking model. It's like, what? What is going on? Like, it was unbelievable. I was not happy. What a waste of my time and money. It's fun. Why do you use a language you don't know? Just one that is useful. Nope. I mean, I had a class called programming languages, and we had to use a scheme and a Prolog and a Lisp and a Java and JavaScript. I don't remember. We had to do a bunch of different languages, and that was fine because that was the idea, right? Teach you different programming languages, think differently. But yeah, if the teacher himself doesn't know it, why? Why? Okay. So somewhere I have a size that's off. What's wrong with my size? In theory, the clay pot is 94 by 94. So if that's not the case, pot something by something. Let's see what it says. If it's not 94 by 94, I'm not gonna be happy. Yep. Exactly. But if it's not a languages class, he should pick a language that he actually knows. I had my analysis of algorithms class was taught by a professor who hadn't taught a class in 7 years. But he was the highest paid professor in the whole department. And do you think he knew analysis of algorithms well enough to teach it? I'll give you a hint. The answer is no. No, he did not. Well, I just forgot that. Pot with pot. Hey, my bad. Yeah, that class was a disaster. Nobody did well in that class because he didn't know it. And the book was wrong. And the test itself had wrong questions on it. So, for example, on the test, there was a question that's like, here's this function. Tell me what it does and what the output is. So this kid who actually went through line by line and figured out what it did, it always returned 0. Because the program itself was wrong. The pseudocode was wrong. It didn't do the thing. So that's what it did. It always returns 0. And he could show why. I recognized it from the book and knew that the book was wrong, so I gave the correct answer. But yeah, he did not get any points back, even though he was correct. But I knew that the teacher was a complete jerk anyway, so. Oh, so frustrating. 94 by 94. So where is this pot, and why is it cut off? Why is this pot down here? It should be up. And you should see the bottom of the pot. I don't like that. All right, well, let's go set a dirt color. Dirt color. I need a color. maybe something like 74.44.0. Set quad color. Two times index plus 0 to whatever that is. Let's see here. It's about 45.27.0. 45.27 and 0. Oh, I better know why. Okay. Let's do this. Zero. Pots. The center of the pots is going to be considered to be 3 times the pot width plus 2 times pot spacing divided by 2, and it will be pot height. That'll be the center. So basically, the dimension of the center pot at the ground level. Set the rectangle to 2. Let's go with 0. Zero, 0, 3 times pot width plus 2 times pot. No, let's not do it that way. If I remember right, texture quad batch recomputes its corner. It's quad, bounding quad. Yeah, there's that too. There are a ton of books used in classes that are wrong for some reason. Yeah. Which does not help if you can't understand the questions. So I actually coded up one of those example algorithm problems in an actual computer, and the algorithm was wrong. It had an off by 1 error in it. It was like, oh. Once I figured that out, it's like, oh, now I know what you're trying to do. I know what the output should be, but shouldn't your programs be correct before you put them into a textbook? That was, oof. That was not good. I was not happy. Three. Pot width plus pot spacing. R.H minus That brown dirt is not very visible, is it? And those pots are still way too low. What's going on here? Is my UV data wrong? Image warehouse, as long as you look at it in the header. Pot, clay pot. Hmm. Okay. How about this then? Actually, set quad corners. Hmm. Doing what I think it's doing. I don't like it. I may not have a choice. Which may be fine. Maybe it's fine. Nope, it's not fine. That image is indeed being truncated. That brown is not visible. Okay. So perhaps what is happening then? $937.20. What might be happening is export UVs. Maybe I need to export the UVs and re-import those. My UV mapping may not be correct. Maybe. Okay. So the clay pot, I'm told, is at 96, 14, 28. 96, 14, 28. Really? 14, 24. Okay, that makes more sense. 14, 24. Agreed. And the width and the height, 94 by 94. I agree with myself. Tools in slash embed pngs.exe. We'll try that out. We'll try this and see if that fixes the pot height issues. Maybe we shifted things in a strange way when I was working on the image off hours. Then we need to put the little tiny envelopes on the blackboard, and a cloud and a sun. I'd like to at least get through all the logic. This doodad today. Get most of the animation stuff done. Okay, fresh, clean, new build. There's the pots. That dirt really just doesn't show up very well, does it? Is there too much alpha? Maybe I need to make it more opaque. All right. I wasn't planning on doing art today, but here we go. We're gonna go to GIMP. Does not look like it's showing what I want here. Come on, GIMP. OBS, what are you doing? All right, I'm gonna close GIMP. Or reopen GIMP, I guess. That's not what I wanted to do either. It takes a minute for GIMP to start up, which is a little bit mind-blowing. There's a reason we're doing the dirt this way. So let's go to show GIMP. Hey, there it is. That's better. Okay. So here's our clay pot and here's our dirt. My guess is the dirt is just too much alpha. Really? That doesn't look like too much alpha to me. That does not look. Huh. I don't think there's too much alpha there, so why? Why is the dirt not showing up very well? That brown does not look like what I told it. Unless I've been doing this wrong. Let's see. Possibility number 1. $124.94. Okay. Alright, so maybe that's the problem. Come here to the cover. These are percent, so 124, 94, 52. Okay, hopefully that fixes things a bit. Ugh. There, that looks more like dirt. Okay, pots are on the board. Now we need envelopes. Balanced expression, integer, num envelopes equals 3. Init elements. Okay, so we get our reference to our envelope, and then we do things to it. Envelope point to set texture, which will be the same texture we've been using. We set UV or set yeah, I think set UV to image warehouse UV key envelope, I think is what I called it. Where's my GIMP? Envelope, yep. Then what? Envelope set clipping entity is add child envelope. Anything else here? Because the envelopes are going to fly around a little bit. So there's the pots. Envelopes. Envelope width. Envelope height. So we'll put those over on the left edge of the board. X equals spacing. Y equals rectangle height minus envelope height. And then for int index. 0 index less than doodad envelopes index. You know what, let's go do this. Num pots. That makes me feel better already. Rectangle environment, rectangle X, Y, environment width, envelope width and height, underscore envelopes. That's not quite right, is it? Let's do this down here. Actually, a couple of different ideas. Okay, let's pause there. I'm going to take a quick restroom break. And we'll go back to laying out some more elements. Be right back. We are back. There's no reason. No, it's fine, it's fine, it's fine. We can do that. We can even move these to a position that we care about, sort of, on the x-axis. Environment rectangle. Environment rectangle. No, that's fine. Move to x, y, x plus equals environment width plus spacing. There we go. One last thing. Envelope. So 0.set color will be some number. We'll put something like let's see, let me find an outline color here. 255 to 25, 183. 255 to 25, 55. I just want to set 3 colors here. We'll make it if we go 55 here, 225, yellow, red, yellow, blue, green. Let's see. All right, let's just try that. Oh, it's not going to work very well. Okay, just a moment, children. What?
So, can I use the go?
Son,
He's eating
son.
all of Mom's cooking.
So where are the older kids? Why aren't they?
I'm not taking care.
Okay. Okay. See if this shows up the way it's supposed to. Nope. I don't see the envelopes. Oh, they're on the render loop though, probably. Oh, yeah, plans. There we go. That should fix that one. Okay. Close our bracket. Okay. There, 3 little seed packet envelopes, which we will make better later. Okay, there's the envelopes. We need clouds and sunshine. I don't really know where to put the clouds and the sunshine, though. I'm not really sure how big they are relative to everything else. Picture plot image of sun. Cloud. What did I call it? Sun. Where's the sun? Sunshine.
Daddy, I'm also changed.
There we go.
Hey, Daddy.
I really should write the convenience method for this environment. To sun. 1, 2, 3, 4, 5, 6, 7, 8. Sunshine. sun and cloud. Yes, yes, no, yes, 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 yes. Yes, yes, yes. Okay, once we get all that, move to somewhere, and the cloud as well. Set center, which will be the bottom edge of the cloud, so cloud height, and the center of the width again. So cloud width over 2. The sun will be just centered. Where to put it though? One more thing we want to do. Okay. Move to somewhere. Start width over 3. R.H minus rectangle dot height. Two times that divided by 3. Actually, these are the same height, I think. Okay. And lastly, when we render, we gotta render those two. Not quite what I wanted to do, but okay. Here we go. So where are we at? December 9th. So Christmas is 16 days away. Oh, how's everybody's Christmas preparations going? Pretty much got my shopping done. And I usually make candy for Christmas. So I make caramel and panucci and divinity. I have not got any of that done yet. So I'm thinking tonight I need to make a batch of caramel. It takes like 4 hours of standing there stirring that pot to make sure it doesn't burn to the bottom. But it's so good. Homemade caramel. Oh, nothing like it. Then my wife dips them in chocolate. So good. So I usually make 2 batches of caramel. One to dip in chocolate, And then another one I wrap around the panucci. So the panucci is it's a non-chocolate fudge technically. Okay. So one question is about where do I want these to end up at? And the answer is centered over this guy. Then as high as I can that doesn't run into stuff. Oh, and they can be scaled down for the pin. Ah, that's a great idea. Perfect. I think perfect. I think that's what we'll do. Okay, so we need 2 positions for the sun and the cloud. So let's play around with the positioning here. Move 2. We want the sun and the cloud to be near a thing. Above the center pot. So if we go to m_pots, actually pot r, actually m_pots, rectangle dot width over 2, actually dot center that, no, what's it called? Rectangle dot h. Middle X, there we go. Middle X. Somewhere. Put it a couple hundred pixels up just to see. We're just gonna put them both in the same place for now, just to see what we get. Because we're gonna need 2 positions. These guys. Let's figure out what those positions are. They go a little higher, so that's 200 pixels up to here from this edge. So maybe like 225. Oh, I'm out of water already. 230. 230. Let's get some fresh water here shortly. Oh, maybe 250. So I skipped my run this morning. I shouldn't have, but I did. I need to do it this evening. I'm trying to whittle down my 3-mile time. It's not very good yet. I'm trying to lose 30 seconds every week, and right now, that feels like a lot. I think 10 seconds off each mile every week. I did too, but I don't remember that one. But okay, all right, that looks like about the right height. I think 250 is it. So that'll be one position. The other position. Oh, I wonder how scale works. Scale to Oh, what if we make it 1/8. I'm not actually sure how center will feel about that. Inf r.x. And y will be rectangle height minus sun dot rectangle dot height. One, two. I just want to see where that ends us up at. Yeah, that's probably not going to work out great. We just need to find these 2 points. Oh, that's right. We have to scale the x and the y. 1.5. 0.625. We'll try that. Well, I can tell you a little bit about why the books in the universities are no good. If you're a professor, how do you get your name out there? How do you get more accolades? How do you get paid more? How do you get tenure? Well, one thing you can do that adds to that list is to publish a book. So you create a textbook that nobody uses except your class. And, oh, there they are. They're right there. Which is not great. We move the scale to somewhere else. I wonder if that helps. It'll move it to a position and then scale around that point. Probably more correct than scale, then move, because that center dimension is a thing. Maybe 1/8 is too small. Well, interesting. Alright, what if we don't scale anything? We got these backwards ending 0, 6, 2, 5, 1, 2, 5. Oh, environment var.x, but rather x plus spacing. Okay, r.h minus sun height. Even if we just get it drawing in the right location. That would be good. Okay, the x-coordinate looks correct. Now we scale. Maybe this is a little too small. So let's, what are we doing here? 1.875? 1.875. 0.75. I doubt the quarter is what we're looking for. 2.1875 over 2. Let's see where that puts us. Basically, we're going to turn some of these into constants later because we need to switch between these 2 points. Oh, good heavens. Okay, and they're really high up. X plus spacing plus sun rectangle dot width over 2 spacing plus underscore cloud rectangle. Now this is sun rectangle dot x plus all of that. And instead of this width, I'm 0.1875. There we go. This plus spacing okay. All right. There we go. There's a sun and there's a cloud. They're a little bit high. Why is that? Rectangle height minus our sun's rectangle. Oh, divided by 2. That's 0.5. I'll bet that fixes that issue. Okay. So this is our start position and our end position for the animation we want to do. That's better. Those look okay. Sun, rain, and little seed envelopes. None of them are clicked yet, but we'll get there. Okay. We've added all the essential elements, sort of. Now what? Good time. Let's see. Let's go to our journal. We've got to add pots of dirt. We added envelopes. We added a cloud. We added a sun. Nothing interactable yet. Rain and sun cycle to grow the plants. Okay, notes. Added basic images to the plants doodad. They all show and have somewhat reasonable layout to start with. Nothing here I don't recognize. Git commit. Added pots, seed envelopes, sun and cloud. 2 plants, doodad. Good enough for a start. Gee, Vanilla, is there anything more I need to do to make indexed drawing? For some reason, I can't draw a triangle with vertices, but adding an index buffer, it simply doesn't draw anymore. Okay, so one thing that I've seen in some render engines is that they will take an array of vertices and they understand you're trying to do triangles and they'll just go 1, 2, 3 as a triangle, then 3, 4, 5 as a triangle, and they can actually work it out as a triangle strip. So maybe you don't need to pass indices. I myself like the control of passing my indices myself instead of having it try to guess what my triangles are. But it's probably that it knows you're doing a triangle strip and it's fine. That's one possibility. If you're passing indices, it might be trying to, well, I don't know enough about it, about web GPU. Web GPU index buffer. There's got to be index buffer list of vertex attributes from the actual order in which they are connected. Yeah, so remove some duplicate data from your vertex buffer, which is more important than large games. Honestly, if you're just trying to quad, you don't save much. Index buffer. Which this example I think is in C++, so not as helpful. Render pass, set vertex buffer, then you set index buffer. And the index format, index buffer size, yeah. Draw indexed. So render pass dot draw indexed is different. Yeah, I mean, just a quick Google brings me this. So you might have to change your draw call. Instead of dot draw, you use dot draw indexed. And set vertex buffer, set index buffer are things you'll have to do. But it doesn't look that bad. Now this is C++, so like I said, you'll have to make a few changes to your Rusty version, but yeah. Funny thing is that in the other project, I have the exact same setup. Yeah, there's always something, and it's usually something silly by the time you figure it out. Okay, so one, we need some states. So let's just fake some. Enum class state is going to include none planting, watering, sunning, row. Oh, interesting. Maybe that's it. Let's just start with this anyways. Equals 0, equals 1, equals 2, equals 3. When we start up, equals chop plants state none. We start with no state. And it works, just not sure what I did wrong now. No clue, probably vertex index was wrong, copied one from the internet and it worked. Oh. Yeah, yeah. There's too many different ways to be able to screw things up. That if you, yeah, once you figure them out and add your personal layer of abstraction that you like on top of it, but always getting through that first one. I remember it took me a while to get my vertex index buffer stuff set up the way I like. And even then, it's not the way I like. Like I would like to add other other things to it, but okay, I need this into plants. Um, so even still, I'm not happy with what I've got. So okay, a lot of this. It's going to be very similar. Oops. Okay, if we're enabled, and if it's within ourselves, so fine. What do I have here? Contains. I don't have. It does contain screen point. I actually want to short circuit much more here. Click. All right, I'll see how that goes. Okay. So we're gonna fake a whole lot of state here. Oh, nurture. Okay, almost there. When it registers the click, we'll start doing the other checks. Okay, so right clicking anywhere else shouldn't do anything except on the board. Good enough. Okay. So the envelopes and the cloud, those matter. M underscore envelopes index. Let's see here. Envelope. Your quad. Contains screen point. Result equals true. So one thing, our state. We'll also need like a plant growth state somewhere else, but that's fine. Equals land, water, and shine. These are the ones we need. Plant, water, shine. Okay, so when we plant, we have to know int index. We do have to know that. Because that will matter. Watering does not matter. Sunshine doesn't matter. Other than state sunning. Watering. Anything. I'm gonna cheat here. We're gonna go with this action sequence. Scheduler to get action sequence with 3 elements. Set immediate action is stage 0, which takes this, does that, and then it's done. Let's set back to none. Into and set a wait in stage 1 for 3 seconds. I don't know. We'll figure something out. Okay. Okay, I think this is going to give us the flow of things a little better. I'm just trying to get the flow here done. Shining. Okay, so we do that. If not result. Envelope 0.2 enabled. And that. Okay. And actually, all of this should be if state equals none. So we shouldn't do any of these other things unless we are sure. Result sun dot contain screen point dot x dot y. Wow. Okay. Shine water. I kind of want to check these before checking plant. It doesn't. Envelope. It doesn't really matter. It's not going to matter too much. Okay. Let's just see if we can keep track of our states here. Oh, oh goodness. Okay. That's a little bit strange. Why would I put that there? And of course, it was copy pasted everywhere, which is terrible. Okay, that is. There we go. Oh, goodness gracious. Oh. Okay, so if we click an envelope with right click, 2, 3, okay. It's not registering these other clicks. There we go, watering, sunning, until it's done. Okay, so these are properly blocking the actions, sunning, cloud, planting. Okay, so that's good. We're at least getting that part good. Okay. So when we click on the sun, we do that. What we need is an animation to move somewhere and then wait and then move back. So this kind of goes back to this. We have a position and a scale there. Sun, you find sun, cloud, scale 0.1875? 0.1875 with sun, cloud, scale. Yes, 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 yes. Okay. Remove that out. Animation. Scheduler. Get animation. Play animation. Sun, cloud, time. We'll go for a second. Why not? X, Y, 3 times. Nope, not that one. Set wait. Sun, cloud, time. The most complicated one is going to be the plant for sure, but that's okay. So we're going to do 2 animations. So let's go to, let's see, we're going to water or sun. Water or sun. So sun. We're going to do sun first. Animation, we need 2 of these eventually. Scale 2. Okay, so the first one we're going to move. Okay, there we go. animation, and scale. Okay. Animation 22 set duration 0.5. 0.25. I think we'll have a couple of wait steps in here. Animation 0.2 set. Easing method. Easing method. Blotting out. Seems as easy as anything to start with. Animation 0.2 set. Range. I'm just going to go from sun x sun y to this x and this y. This float x, float y, underscore sun dot move to this x, y. Let's do this. Float x 0 equals this. Y is 0. Just for readability. This will be x1. Wow, okay, there we go. Y1. Okay, then our sequence. Play animation. Stage 0. Animation. So I'm going to do move, move, wait, expand, wait, shrink, wait, move. 7. I need 7 stages. Set, let's see here. Action index equals 0. Action index plus set. Weight 0.125. It does not need to be much. Action index plus. We get a new animation. We do that. Set range from sun cloud scale to 1. And the way we apply that is this float value underscore sun dot scale to our value. That's that. Then we play that animation, and we don't need this wait, we need a long wait, which was the sun cloud time. When it's done with that, basically do this thing again. 0.125 seconds. And instead of 1.0 to that, then a brief wait, and then this animation basically over again. From x1, y1 to x0, y0, which is where we came from. We move it to there. Set play the animation. Action index. Okay, so we have move the sun where it is to above the plants, wait. Scale the sun, wait. Shrink the sun, wait. Move the sun back. Then we're done. I think that's it. In theory. Let's see how that goes. This is the easy one. Wait till we get to the plants. Oh, goodness. Let's see if that works at all. Okay, click the sun. Oops, right click the sun. If we right click the sun, it blows up. Okay, all right. And then it blows up. Okay. 7, huh? Action index. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. No. 0, 1, 2, 3, 4, 5, 6, 7. So that's 8 of them with an max index there. Nope, not for me. If only I can count. Hello, I'm doing great. How are you doing? Sea films? I'm doing great. We are adding the last doodad today, at least the states and some of the basic animations. The more complex animation will probably be tomorrow, but we'll see how far we get. Because this one has some fun little interactions. If we right click the cloud, okay, but this is the one that's we've animated, so click, whoop, back, and it did not shrink. Okay, I thought we had the scale in there as well. Let's go figure it out. Quit. All right, plants. Get an animation, get an animation. Oops, this one, I'll bet. This was the move back where we came from. And markers done. I think that's no problem. Fix that. Uh-oh. What happened to my internet? Nope, wasn't that. Okay, well, shoot. Unplugged my internet. We gotta wait. Gotta wait for the internet to come back. Always takes a minute for that router to reboot too. It's too bad. Too bad. I don't like doing that. Check our mail while we're waiting, I guess. Woohoo, DMV gets back to me. Just waiting on the internet. There's that one. I've been waiting on this one for a while. Perfect. Have to take care of that. Probably tomorrow. Okay. Still waiting on the internet. Patiently waiting on the internet. Always so patient. My setup here's not very good. I'm not gonna lie. Although it's been a while since I've kicked the cable loose myself. Most of the time it's one of my younger children who's unplugged it somewhere else outside this room. Alright, internet should be coming back up any second now. How about now? Any second now. Most of the lights are green. And the internet's back up, I think. So we're good, I think. Yes. So I don't think Twitch reconnected. Darn it. Alright, so I'm going to stop streaming and restart streaming and hope that brings it back. So hold on. Oh wait, no, I think we're good. I think it'll reconnect. Alright. Sorry about that. Router unplugged, rechecking my audio. Make sure that all came back up, right? Okay, I think we're good. So sorry about the disconnect, folks, but we are back. So C Films. Hopefully you're doing good. I was looking around your webpage the other day. It's kind of interesting, although I'm not really a Seattleite type of person or a Washingtonian at all. Okay, let's see. Back to it, right like the sun. Okay. I would argue it could spend a little bit longer there. That's fine. Watering. Done. Sunning. 1, 2, 3. So as soon as it comes back, I should be able to do it again. Okay. Okay, so that's one piece of it. The other thing we want to do is change the color of the dirt. There's that phone again. So instead of this wait action here, sun, let's see, where is it? Sun and cloud time. We're actually going to get another animation. Set the duration to sun and cloud time. Set range. We're going to go from underscore pots dot get quad color. Is that a thing? Or just quad color? Nope. Guess we don't have that. That's fine. We can just do it up here. Dry dirt color will be a thing, which is this one. Dirt color dry. Dirt color wet will be something else. Let's go find a quick color here. Something like that. Let's go 81, 82, 53, 82, 53, and 12. Dirt color dry to dirt color wet. The application is to take this thing, color C, and we apply it like this. For it, index equals 0, index less than doodad pots. Then underscore pots dot set quad color 2 times index plus 0 to C. I think that's basically it, actually. And then we play that animation. So we're just changing the color of the dirt from light brown to dark brown. It should be the other way around, but okay. We just want to see it do something. Make sure the animations are working right. Let's see here. String disconnected. Restarted. Router should be back up now. So yeah, sorry about that. Okay, let's go in here, run it again. So if we run sunshine, okay, that turned a darker brown. I think we'd go with an even darker brown, where we need to worry too much. But that's the wrong direction anyways. So, one thing I need to know is chalk plants. We need a new state. Enum class dirt state, either dry or it is wet. Dirt state, dirt state. Equals to get chalk plants dirt state dry. this one. Nope, not this one, this one. Start color equals if we are dry, then we use the dirt color dry. Otherwise, use dirt color wet. We go from our start color to dry. You know what? How about we just check this? If we are already dried out, then we just wait. Underscore sequence to set wait at action index plus plus for sun and cloud time. Otherwise, we get the animation. We go from dirt color wet to dry. We do that. Okay, so that's probably better. Anything else we need to do here? We wanted a darker brown potentially. We just find it even darker brown. 7347. 47 and 10. Okay, we'll try that. We'll click the button multiple times just to make sure that it stays dry and looks dry. Okay, so if we right click the sun, there we go. Right click it again, doesn't matter. Okay, we need to get the cloud going so that we can get the ground wet. That'll show us everything else we need to know. But, all right. Shine. So much of this is going to be the same into rain, water. Go backwards. So let's start at the top. Watering. Underscore cloud. We're going to get our position. We're going to get the target position, which is fine. We're going to move it to there. We're going to scale to something. This is kind of awkward. We'll come back to that. And the same thing with that one. The move is easy. Move, move. Oops, not those two. Then we just swap these. Then we go from dry to wet. If we are already wet, we don't have to do anything. We just wait. Which one is this one? Interesting. So the scale 2. has a very small duration, 0.25. Sun and cloud type should only appear once, really, in this chunk. Up here. Oh no, it's fine. I don't know what I was looking at. Okay. Anything else? Oh, in the last piece, right here, underscore dirt state equals. This is the thing we need to do. Dirt state is wet. Then down in shine, it goes to dry. The cloud is not going to work well. So let's go back to cloud. The scaling ones, basically. So we're going to go from X scale times 0.5, Y scale to 1, 1. Scale X, float scale Y, scale X, scale Y. The other scale is this here. We swap. That's basically it. We go from 1 to the compressed cloud. We capitalized that when we shouldn't. That is one thing I shall have to decide eventually. Hey, EC Films, how's my project? Project's going pretty good. We're on the last of the chalk doodads. Basically, chalk doodad is something on the chalkboard that you can interact with while you play, just like as a fidget. Like in Hearthstone, the interactable environment there. Not quite as cool, obviously, because I'm a solo dev and not an artist. But we've got a bouncy ball, we've got bubbles, we've got an archer, we've got a solar system and a rocket, and now we're doing plants. So we're gonna be able to sunshine on the plants, water the plants. If we do that again, it shouldn't change anything. And sunshine should dry it out. Nice. So we're getting there. Boom. Wet dirt. Dry dirt. Perfect. So I think that's pretty good. So we're gonna get the chalk doodads done. I've got some optimizations, finalizations, finalizations of pieces, and then we'll release, probably not this year, but next year. It's just, everything takes me a little longer than I'd expect. So we're sunning, we're watering. That is not bad. Click sun to wet or dry. Now we need to do the planting of the seeds. Sun cycle to grow the plants. How is your project going, C Films? How's your website? I did a little bit of poking around. It's pretty interesting stuff. But I'm not really a web developer. I'm much more interested in your programming language stuff. But that's just me. Even something simple for programming language development is very useful and instructive. Right. I'm going to take, I need to heat up some water. Heating water for Sherba. Be back soon. Yeah, I'll be right back, I promise. Okay, I'm back, and for whatever reason, I totally forgot that I have GIMP up here. What's going on here? Terrible. Okay, well, we're back. We're back. We're back. So, the sun and the cloud now do things to the dirt. Let me think. I do want raindrops to fall, which means in my render function, the cloud needs to render before the pots. Raindrops. Which we'll get around to. Do get around to raindrops right now. Interesting, interesting. Maybe do raindrops now. Why is that not in the old journal? Journal. Raindrops falling. Okay. Made a cloud. Constant expression. Int num raindrops. Something like 12. Texture quad underscore rain. Number of raindrops. Number of pots, number of envelopes, number of raindrops. Static constant expression int num children equals number of pots plus number of envelopes plus number of raindrops plus 2 for the sun and the cloud. We will also need a seed eventually, but we'll get to that. All right. Children. There we go. Two times number of pots. Okay. Not too shabby. Here we go. Sun, cloud, rain. Actually, let's see here. Rain was called if I could get to the right window here. Raindrop. Texture, UV rectangle, and center. Sure, that's fine. Rain drop. And every rain texture quad. Do that. And rain point to enabled equals false. Okay, that's part one. And rendered. Render. Okay. The trick now is we want a bunch of raindrops to fall from the cloud to the pots or the ground. And it only matters when watering, not when it's shining. Here, this one. Ooh, let's see here. To do animate raindrops. Whether we change the color of the dirt or not, rain should fall. Sun and cloud time. Each raindrop, what did I say? There's like 12 of them. So we kind of want each raindrop to pick a random location along the cloud. And then fall. So we're just going to chop this together real quick. We need... Oof. Need each raindrop to get a position in the cloud and then fall somewhere. And upon hitting the bottom, just disappear. Change the sun and cloud time. Like 3 seconds. Which means I need a subsequence for rain. Action sequence, subsequence, scheduler, get action sequence. Number of raindrops. That's how many big it needs to be. Let's see here. So we need 9. Because our sequence said start, subsequence, at action index, okay. Now each raindrop needs a raindrop sequence. Index less than chalk plants num raindrops. Action sequence. Drop sequence. Get an action sequence. We'll go 3. No, 4. We need 4. Drop sequence. Set immediate. Let's get the raindrop itself. How about that? Texture quad. So capture drop. Enabled equals true. And setting a position. Move to XY. So for each raindrop, move it to a location set it to visible, and then we're done. Somewhere in the end, enabled equals false, which is easy enough. Actually, set weight is probably the first thing, 0. Matthew RNG, next float up to some amount. We don't want all the raindrops falling at the same time. So we wait, we move it somewhere, and x0, y0. X1, Y1. We wait, we move it, make it visible. Heyo, L side kangaroo. How's it going? So far, so good. We've got sun and cloud, we've got wet and dry dirt. We're gonna make the raindrops actually fall here shortly. Then we'll need to plant the seed. Then we'll make the growing cycle. Even if the grow isn't fully animated yet. I'd like to get to that point today, so. Drop sequence, we wait for some random amount of time. Move enable, and we want it to drop. So let's just go with next float from cloud left to cloud right. It's okay if it's a little bit off. It doesn't matter too much just yet. We'll fine tune that rectangle dot y. X1 actually doesn't matter. Drop X, Y0. Y1 will be there, I guess. When you describe the plants and whatnot, that I was thinking, is he making a new game? But yeah, it's a doodad, right? Yep, it's a doodad. Just a doodad. It's gonna be interesting. So we need an animation equals scheduler hit animation set duration. Probably be like a second to fall down. Set easing method easing method, and I think quad in set range. We're gonna go from x y0 to x y1 of our drop. Put y, then we just take the drop, move to x and y, and then drop sequence point to set Play animation. Step 2. This animation. So 0 is wait 1, 2, 3. So that means that this drop sequence needs 4 elements, which is correct. And then the subsequence set start subsequence to index drop sequence. I think that's it. Let's just see what happens here. Yeah, we're gonna do a bit of fine tuning on this. We just need to get something showing on the screen. No, each of these doodads is like a mini game, I guess, but there's no point to them. They're just there to interact with. Although each of them is kind of like a microcosm of a game we could write. I had this idea pop into my head for a game. I wrote a bunch of notes down about it yesterday, day before. Oh gosh, when was it? Saturday? And I might combine it with another game, like very simulation heavy, sandboxy. Oh, apparently, probably have a typo somewhere above here where we aren't properly. There it is. What was the idea? So, a spaceship, but highly simulated. So you'd buy a chassis, then you'd buy different nacelles, but each chassis and each nacelle has different requirements, like energy requirements, water, cooling, gas, fuel, nuclear. So you have all these different pipelines and connectors, and you have to connect everything to make the ship run. Then running the ship also takes like understanding of where is the energy being put to, how much do I have available, can I put more into my front shield, so it's sort of Star Trek-y like in that way. But yeah, super simulation involved, but that wasn't like the main point. The main point was I want to randomly generate an alien race or species that you make first contact with. And so like there's a whole societal, cultural, what biome did they grow up in, and what's their motivation, what are they trying to accomplish, and do you need to stop them or help them? Like you have to deduce all that without being able to communicate with them based on their actions. So maybe sometimes you're on the game and your whole mission is to destroy them before they destroy you, but can you tell that? Are they carnivorous that are trying to eat humans, or is it their planet's being destroyed and you have to find them a new home while not letting them colonize your home? Or is it they're being invaded and so they're running and you're just happen to be in their path? All sorts of things like that. Maybe some of them are silicone based, some of them are carbon based, some of them breathe different amounts of things or require different environmental biomes. So it's more about deducing from what you observe of the alien behavior, what do they need and how can I not die. Yeah, more like an open explorer. Yeah. But I think that would be the key is, the aliens designed would be very random. And maybe I can't make them random enough to make it too crazy, but like there would be a bunch of different combinations. So rain. I don't see any raindrops, so that's sad. Sun dries the dirt out. Rain makes it wet, but there should be raindrops falling here. They're not falling. So that's awkward. So in other words, the behavior of the aliens would have to be procedural, but logical. you played enough games, I suppose you could eventually reverse engineer all the different combinations of what the aliens can do, but first couple of times would be different and interesting. Okay, that would be cool. The building reminds me of Factorio. Yeah, it would be a little bit, I don't know, like FTL or Factorio or, you know, something like that. It'd be an engine builder. And their exploration makes me think of Stellaris. Yeah, yeah. Kind of like that, but the main conceit would be deducing aliens' weaknesses, aliens' strengths, aliens' you know, motivations without any way to communicate with them. So, could be kind of fun. Maybe my idea isn't unique enough yet, but it would be a fun one to play with for a little while anyway. Yeah, a little bit of a Factorio, but size to your ship. Okay, so let me think. I'm trying to decide if I want like crew simulation where the crew morale and the supplies all have to be run correctly. Life support. I don't know if like running drills would be a thing. Oh, I know. There's so many different directions, but like I wrote down all the things I could think of, like crew morale. If you don't have enough food on board, you do have to ration it. But you have enough crew quarters. Is there enough room in the cockpit? You have enough engineers to repair stuff. Like you'd have to build up your own mini economic empire to run your ship. So part of it is, farming the resources you need, buying the tech you need. So kind of a survival game too. What would be the core game loop? So one is gathering resources, buying and building updates to your ship, then flying around. No matter what you do, you're going to run into an alien. And then your goal is to, like I said, deduce everything you can about the alien just by observing it and interacting with it and trying to, survive. Whether that's helping the alien or destroying them. Destroying them isn't always the goal, though, right? Maybe sometimes you get a random run where the alien's really easy to destroy. In others where it's not. So finding an alternative way of dealing with aliens is desirable. So yeah, could be interesting. The raindrops aren't falling. Oh, well, hold on. Where is the thing? Rain. Add child. We didn't do that, so positioning might be an issue. Yeah, aliens aren't default the bad guy. Exactly. I'm trying to decide, like, how would you punish somebody for wiping out aliens if they didn't need to be wiped out? Would that be, how do I punish that mechanically without making it artificial, right? Because technically, you run into aliens, you destroy them, well, you have survived and your species has survived, or your colony or whatever. But that may not always be the optimal solution. So how do I punish somebody that's just like, oh, I'll wipe them out every time. I'll just nuke them. I'll race through the tech tree to the nuke and win. Like, that's not desirable behavior. Oh, there's raindrops. Okay, so that's much closer. Good. Raindrops appeared where the cloud was. Okay, all right, so that's not bad. It'll be a lot more simulation heavy, and that would be pretty kind of cool. Like I said, lots of open ideas still, and you'd have to test each mechanic to make sure it works. But I think it could be fun. So if we are in watering, we do have the cloud X and Y. honestly, who has time to build all that? I've got more ideas than I have time to work on them all. Okay, so in this case, we want this a little bit different. URNG point to next float from here minus m_pots rectangle. Actually, just from x _pots rectangle dot right y 1. This is just ring x ring y1 should equal where the cloud ends up, which is y1. Okay, let's try that. Yeah, I feel like figuring out how the core gameplay would be the main step. Yeah, then everything else could scope out from there. Yep. Sometimes I get caught up thinking about all of my ideas. I'm glad I'm just working on Pong right now. Haha. Yeah, but I have a problem. Like I have text documents clear full of ideas. I've got one for computer games, one for tabletop games. I've got one for like computer programs that aren't games. There's just so many things that I could be working on. I need a team of engineers to work on all the projects I want to work on, but I don't have the money for that. So I gotta build it myself. Hey. So the rain falls. It's not great, but it is there. And we're rendering the rain after the cloud, which I think is backwards of what I intended. So in plants, I want to draw the pots, then the rain, then the cloud. Right, so we've got to keep the scope small for now. Nothing wrong with that. Yep, exactly. Exactly. Okay, cloud. I feel like the rain is coming out in front of the cloud a little bit there. I want the rain to be obscured by the cloud. Can I not build it? Maybe I didn't run a build. No, it looks like I did. The pots, then the rain. tend to start from my game design from a mechanical point of view, and then I add themes to it, which isn't always the best way to do it. I don't feel like it's getting all the way over that pot. Which I guess is okay, but I mean, water. Middle X. Temper X equals this. Temporary width equals m underscore cloud dot rectangle dot width divided by some cloud scale divided by 2 between temp x minus temp width, temp x plus temp width. And I don't actually want this to cover the full 2.875. Basically just coming in from the edges of the cloud a little bit. Okay, let's try that. Maybe start with simple, crazy ideas. Where I want to make a game that changes its linear storyline every playthrough. I was thinking a 3-level dungeon crawler where story archetypes are used to generate the story. Hoping I can scope the game super small. Yep, 3 levels in a confined dungeon and focus on the linear story system. Maybe start with simple text replacement of nouns and adjectives, make it more complicated from there. But of course, different characters and events generated based on a seed. Yep, I can go on and on describing the big games I have in my head, but I've got to make basic games first. Yeah. So one thing you might consider, let's see here. Sorry, it makes me think of things like where was it? Here, this one maybe? I'm not sure this link, let's see here, where's the link? Copy link. This one. Try this one. So there was the Nemesis system, which I think was in one of the Warcraft, one of the Lord of the Rings games, maybe. Middle Earth: Shadow of Mordor. That was it. But this one describes the system pretty well and what worked and what didn't work about it. It's kind of cool. Oh, I know what you're talking about, and their darn patents. Yes, but as long as you did it a little differently, it's not covered by the patent, right? It's sad that they can patent algorithms, or it just makes me a little bit mad. But it's that idea. That's kind of what you want to go for, right? You want to generate some characters and then let them go in the world, and the story sort of evolves from there, right? From a seed and how you interact with that seed, right? Okay. Come on, little cloud. Well, it's not divided by 2. Oh, it is that divided by 2. I know what's going on. It's not divided by 2. That actually goes away because our width is already scaled by 2. We do that. Perfect. Okay. Why are these raindrops being rendered on top of the cloud, though? That's the part I don't get. Is there that much alpha channel in my cloud? It actually is pretty alpha. If I put on a black background. I think I need to remove the alpha channel from this cloud. Or not remove the alpha channel, but replace it, recover it with something else. Let's see here. Paintbrush. Let me duplicate this layer. Oh. Duplicate it again. Background, paintbrush. So you probably can't see what I'm doing. So let me go do this. Show the GIMP. I mean, true, software patents just make me mad in general. Yep. But yeah, the management of the enemies and the way they generate their story in the background in this game is cool. Exactly. And it's that simulated enemy. That would be a really cool idea. I like the idea. And I think that some of the ideas from Nemesis could be a good seed for your project. You just have to do it a little differently, right? And you know, I'm no lawyer, so I can't exactly tell you what to do or avoid to dodge the patent, but there's got to be a way, right? I would hope there's a way. Okay, so if I make this, what's the best way for me to do this? Maybe if we turn off white and black, and I just black backfill everything. If I do something like this, I'm going to trace the whole outline. It's okay if there's some alpha around the edges. I don't mind that too much. I think my cloud is just too much alpha. Like, I definitely plan on violating some patents in a creative manner when I write my own font renderer. I guess there's patents around the winding algorithm, which kind of blows my mind, for determining what's inside or versus outside of the curve. You don't actually have to check if it's inside the curve or not. So that should be an outline. Oh, darn it. Shoot. That's an opacity thing. Which means I kind of need to redo the outline. I'll turn the opacity on my brush up. Oh, nuts. This doesn't have to be perfect either. It's really just the raindrops that have to show through. Okay. I need to release the mouse more often so I can undo a bad trace. And it is setting on a black background, so, well, a nearly black background, so it shouldn't be too bad. If we miss a few spots up. Yeah, I would love to build something like a Nemesis system for a more complex, RPG experience. I don't think most of the games I've got planned right now have RPG elements in the computer side. I want to do like a layered RPG experience though, where like you can choose to be a low-level person, like soldier on the ground actually doing the fighting, or you could be like a commander where you command a squad, and like your interfaces would be different, but the people you command are other people who chose to be soldier types, right? So you kind of have a chain of command that's built up of actual people interacting with the game systems in different ways because you have different views. Like one of you can actually see your squad's budget or whatever. Not that one. What did I just turn off? So we turn off white. And then we merge the cloud down. Turn off that save. Export. None of the UVs changed, so I shouldn't have to worry about that. Okay, let's try re-embedding that data. Oh, let's see here. I was looking at Dwarf Fortress. Oh yeah, and Caves of Quad. The way they generate their histories is cool. It is. Did I draw that? Yeah, I drew most. Well, either I or a friend of mine drew everything in the game. Maybe just feign ignorance. Software has patents. I never knew. Unfortunately, ignorance of the law is not a defense. They made sure of that. So what they do is they still slap you with fines, and you got to cut them a percentage of everything, and blah blah blah. It's all very sad. So basically, they'll take all of your profits from you, whether you knew or not. But the problem is, things like judges have no idea how software works or what isn't patentable. Like they just don't know software. They're a judge. They're legal. So how would they know what's patentable or not? Which is again kind of a stupid argument because a judge should know what kinds of things they're reviewing to grant patents or not. But I guess it probably isn't even a judge. It's just a patent clerk. But yeah, either way. So like I said, you just have to make it different enough that you can be pointed and be like, well, mine is different. It's an improvement over their system because of this, and then you've superseded the patent, right? It's only if you copy the patent that you're in trouble. You have to come up with an improvement. Which hopefully isn't too hard because they haven't done anything with it in a long time. And we have modern AI. You could feed ChatGPT as part of your Nemesis toolchain, right? Or your Nemesis replacement. There we go. Now the raindrop's falling out correctly. All right, part one. I mean, don't that have they have patent lawyers? Yeah. And the real problem is if you look even vaguely like it, their patent lawyers can get on you, and you can't afford to fight. They'll just bury you, even if you're right. They'll just bury you in legal. They can afford to drop the whole court proceeding until you're broke, and then steal all your profits after you've run out of money anyway. You just can't afford to fight the big companies. But if you're running a text adventure, and if it's not obvious that you're doing Nemesis-like things, they might decide it's not worth it to even have a patent lawyer go after you. They might be like, well, they're too small to go after. I don't know. Okay. So we're dropping raindrops. And what? We need to do two things. We need to determine how far to drop the raindrop. So where's that? Okay, so Y1 is not correct. That's the lowest it could go. But if we're over a pot, we want to be some amount of the pot height up from that. So for example, if temp x, actually if rain x pot width let me think about this. We need pot width and pot spacing. That's basically what we need. So pot width and spacing. We get our pot width, we get our spacing. Rain x. If rain x. So there's three ranges. We have three ranges, range from the middle of all the pots. Temp width. We're going to do this. I'm going to pull this outside the loop. This doesn't change. Look, pot 1 x 0, pot 1 x 1 equals temporary x minus pot width over 2. Pot 1 x 0 plus pot width. All right, now we're getting there. Pot 2 x 0, pot 1 x 1 plus spacing. Pot 2 x 0 plus pot width. Pot 2 x 1, pot 3 x 0. X 1. So I have 3 ranges to check now. Okay. Pot 1 x0 less than equal to rain x, or rain x. Oh, and rain x is less than equal to pot 1 x1, or pot 2, or pot 3. If we're over a pot, in other words, then our y, rain y1 equals, or minus equals, our pot height times some number. Let me do a little quick math here. Our pot is 94 pixels high, so from 1918 to 1844. 1918 minus 1984 is 66 pixels. So 66 pixels over 94 pixel height, 0.7. 0.7. Let's see what happens. Yeah, too many games to make, too many games to play, too many systems to learn. Okay. So the raindrop should fall on the pot. Sort of. Not great. I feel like that one wasn't that bad. I know it's wrong. Temp minus this, and another pot width, and another spacing. So basically, we're on the center pot. Move halfway off the pot, move off the space, and move off the pot width. That'll be the first pot. Maybe we have to get more raindrops. Maybe go to 24 or something. We'll see. We'll see. We're also going to cycle them. They're not going to fall once. They're going to fall 2 or 3 times over the time we have. Icteric. That wasn't too bad. Okay. Now that is 4 times through a cycle. We want it to fall 3 or 4 times. I honestly like animations defined as code. I feel like it's easier to read. I want to make an animation editor in my engine, but I kind of feel like I would get more mileage out of just exposing the functions to manage my animation from scripts. Yeah, I tend to think code myself. I feel the same way about node graphs and whatnot. I feel like visual coding, like Unreal's blueprints, gets confusing for me. I think blueprints is designed for the level designers and the artists, not for the programmers. I think programmers use blueprints, but I think it's more for non-programmer types. I was watching AK Element stream. I saw he was making a node graph for this renderer too, I think. Yeah, no, he seems solid. He seems like a good programmer. And yeah, his node stuff looks pretty good. I'll be curious to see where he goes. I think he's gonna finish up some more render engine stuff and then make his own game with it, which is good. If you're gonna make an engine, you should make a game with it. That way, you're using it and forcing it to be tested by yourself. So I'll be curious to see what he comes up with. Okay, so let me think. If we make this 7, 1, 2, L1. We just go 8. Maybe we go 8. We compute a new X for a raindrop, a new Y, and a new Y1. And we wait for some random amount of time, redo an animation, and then shut ourselves down. So actually it's this sequence over again. So that's 1, 2, 3, 4, so that's 8. 5, 6, 7, 8. Maybe. Maybe just do drop count. Int drop count equals 3. Over times drop count 4. Int index equals 0. Index less than drop count plus index. Sequence index. Drop sequence index. Drop sequence index. Okay, so for each time we want to drop this raindrop, we're gonna hold on to the drop. We're gonna get an X, a Y, and a Y. We're gonna wait for some amount of time, which will be int drop sequence action index equals 0. Plus, play the animation for the drop, and then clean up. So each raindrop should fall 3 times. Maybe. Oh, Okay. It's kind of there. One thing we don't want to do is wait here. Rather, what we want to do is... Did you ever try using Chatty? Nope. Another streamer recommended it to me. It plays the sound when people chat or follow or whatnot. No, I've not done Chatty. I somehow got it so that it'll tell me when someone follows. But no, I've not used Chatty. Maybe that's something I should look at. Twitch chat client. Okay. All right. Yeah, I'll take a look at it. All right. Been drinking a lot of water, so quick restroom break. Then we'll be back to make the rain look better. Just a minute. Okay, cool. I usually have it running in the background when I stream. Okay, for sure. Also, you don't have to. I just figured I'd mention it's really hard for me to focus on a lot of things at once, so it helped me a lot. Okay. Yeah, that might be helpful. Okay, so here's the thing. This weight. If drop sequence index is 0, we want to wait longer. Otherwise, we don't wait very long. So we want to keep the raindrops flowing. One other thing. Drop equals that. Float drop time equals 0. Float segment time equals segment time equals 0.25 equal to the segment time, and the drop time. Oh, let's see here. If drop time is 0, drop sequence set wait, drop time plus equals segment time. Immediately get animation, which has a duration, drop time plus equals. Let's make this a little faster. I feel like we can drop the during drops faster. 0.75. And we want to ask the question if, not for drop count. Drop count is not a thing. While drop time is less than sun cloud time, that's 0.75. Which we need to do something about. Pound define rainfall time is 0.75. Drop time plus how long it takes to fall, blah blah. Let's just try that and see how that looks. Oh, we don't have drop count. Four times rainfall time and the sun cloud time divided by that, 4 times this integer. Some of them might never be used, but it's fine. Just want to see if we can make the rain look a little better. We may need to increase the number of raindrops just to be sure. But if this starts looking better, and maybe that 1 second isn't a thing, let's see. Right click. Oh, how cute. That's not bad. Rainfall. There we go. I think it needs more raindrops. Let's go with 24. And one other thing we want to do, elements. Clouds at center, rain. Set color to cover 255, 255, 255, 128. We're just gonna make it a bit alpha. Change our memory layout, so you have to do a tidy up. Wait, so how does the action sequence work? Okay, let's do that while this is building. I guess I haven't opened up action, etc. since. And action has a type. So if we say pass in the update loop, the action is just marked as done. If we say immediate, we pass in a function pointer and say this is an immediate action. A frame means do this function and then don't proceed to the next frame. Wait just has a timer, so there's a timer. And do until, I can pass in a function that says here's what to do while we're waiting, and here's how to test if we're done. Blah, blah, blah. In the update, if it's an immediate or a single frame or a wait for completion, it runs the update. And then otherwise, it's waiting for something, in which case it's not doing anything. There's no update function. Then we ask, are we running? Wow, okay. Whoa, okay. So if it's an immediate, we run the result. Yeah, so it runs the action. So, for example, there are some convenience methods like play animation. So when we start this action, it starts the animation, and then we do nothing until the animation is complete. Same with like play sound. We start the sound and we return true when the sound stops playing. Okay? So we have some nice convenience methods this way. Sometimes we don't wait. So start animation just says, just start it and don't wait. So then the action sequence is literally just a number of actions. So we request an action sequence from the pool, and we say, hey, we'll resize ourselves to have the right number of actions. We'll go through each of the actions and clean them up. And then we'll return this action sequence in a state. It's waiting to get started. So in plants, get action sequence. So for example, an action sequence with 3 actions in it, we immediately set the state, we log out that we're planting, we wait for some amount of time, and then we set the state back to nothing. That's kind of what the action sequence does. But in the case of watering, it actually gets a lot more complicated. So maybe sun is a better place to look. So the scheduler handles sounds, animations, action sequences, keeps track of who's running, what's running, keeping them updated in the update loop. So shine, we say we have 8 things we want to do. Step 1, so sequence set play animation is at action index 0, play the animation. Then in index 1, we wait for some amount of time. So this is the sun moving from where it is to where we want it. Then wait. Then we get another animation that says, hey, scale up the sun to its full size. So that's another animation at index 2. If the dirt's already dry, then we don't have to do anything, we just wait. Otherwise, we change the color of the dirt over time with another animation. So these would be at the same step. Step 3. Then we scale back down. Then we wait for 1/8 of a second. And we do one more animation to move back to our home location. Play that, and then as soon as we're done, then we update our state. That's what the action sequence does. It lets me queue up a whole bunch of things and say, go take care of all this. Start the animation, start the sounds, wait for this thing to finish, set the state here. And it just takes care of that whole sequence of things for me. So I hope that helps. So in this case, the rain action, the rain function creates a sequence of actions which moves the cloud to where it goes, scales it up, drops rain while it's changing the colors, and then it zooms back down, and then it returns to its home location. That's kind of the sequence of actions that does when we right-click this cloud. Rain, rain, rain. Oh, That's not too bad. I think 24 raindrops helps. Okay, then we click the sun, dry out the dirt, water the dirt, it turns darker and darker. Eh, not bad. We got the raindrops. I think maybe that alpha is a little too alpha. We don't need the alpha. Yeah, so the action sequence, the heart of that is in the update loop. All it does is say, while we're running, update the current action. If the action is still running, we're done. We keep going. If the action is not running, then we move to the next action. And as long as we're still running, we start the next action. If we're outside of the running, is outside of the array, then we stop ourselves. We go to idle, and then the scheduler cleans up everything after it's done. Once it says, oh, you're at idle, we'll take you out of the running loop and put you back in the available queue. This is just a pool. All these actions are getting reused all the time. I did not change the alpha channel. Why am I running again? 128. It's maybe like 192. Yeah, so the scheduler has two jobs. It initializes a whole bunch of pools of things. Come on, scheduler. Here we go. All right, where are we? So process sounds in the normal. Let's see. Let's just do the update. All right, where's process? Here it is in the update loop. We process what sounds are running. Then we process the action sequences. Then we process the animations. And all it does, so there are two things. It gives us an access to a resource. So we go to action sequence. We say, hey, I want an action sequence. It says which ones are not busy. Oh, this one's idle. You can have this one. So we'll initialize that action sequence and return it to you. Same with get action. It's basically a convenience method for a single action sequence. Get animation. Again, it says, hey, who's not busy? You can have this one. Same with sound. So that's one, it's a pool of resources I can allocate. Two, in process, it goes through each animation and it says, oh, I thought you were busy in the animation pool. If you're complete, then you're done. Otherwise, go through each one that is running and update it. And then basically the accounting stuff. So animations are kept track of here and made available or unavailable. Process action sequences, same thing. There's a sequence that needs to be queued up. If the things are in waiting, we try to start it. If they are running, we update them. And if they're done, where's the complete? There's no complete. Oh, the action sequence marks itself as complete, so that's fine. We're going to change the way that works eventually anyways, but that's it. It says, here's a resource that's available, and I'm going to keep track of that resource over its lifetime. Yes, exactly. Yep. It's actually been really nice. Like, this is one of the things that I'm going to bring up in the post-mortem. I think the action sequence, animations, sounds, and animations, that worked really well. There might be some other things I should stuff into the scheduler, but just having those three resources as a pool and having their life cycle entirely managed by the scheduler has made a lot of things super nice. I don't know how they do it in real games, but you know, this is why I don't want to watch too many YouTube videos about here's how games work and here's how you design the engine and here's how you build stuff. Like, I think sometimes, depending on your game, you need to design your own systems, and this one has worked out really well for me, I think. So we just made the rain slightly less opaque, or less transparent. Yeah, those are the basic building blocks. You have an action which starts things, on when the action starts, it does things. During its update, it does things, and when it terminates, it does things. And then from there, you can easily abstract out starting, running, and cleaning up an animation, or a sound, or something else. And then that has an action sequence, so you can put these actions in order. And then you have the scheduler, which maintains the life cycle of those objects. So overall, not too shabby. So we're gonna try this with more alpha, less alpha, more alpha, less transparent. So if we rain, that looks okay. The sun comes out, lovely. As long as it's doing one of those, it can't do anything else. Raindrops falling. Cool. We're gonna call that done. As far as rainfall. Cool. Raindrops falling. Raindrops fall from the cloud and disappear when hitting the ground or a pot. Sun and cloud animate to location and change the state of the dirt. All right. Not too shabby. Yeah, no, it's a good abstraction where the engine can handle the scheduling and the API is clean. I want to set up something similar. I just wonder how the abstraction would look using my scripting system. Yeah. I mean, I imagine the API would be somewhat similar. Request access to a resource, and it would go through the pool looking for something that's in an idle state. However you track that. I think I made a mistake in the beginning, but that's doesn't matter here. Then if it's idle, you just return it, and it moves to a waiting state. It means somebody's requested this resource, and I will start it on the next time I run my process. I'll call the on start function pointers and so forth. You're doing C++ scripting, right? If I remember right. Yeah, it's like the fundamental is scheduler get resource mark it as waiting or queued or something, That's the thing that should be available everywhere. And then update basically says for each resource in the pool, if waiting, start it. For each resource in the pool, if complete, stop it, mark as unused, as available. For each resource in the pool, run the update. It's actually more like that. So you might start one, and in the same frame, it will do the update, and it will complete. If it's all, things that just need to happen in sequence in the single frame, it can do that. That's basically it. Initialize resource, initialize set resource to a known state. Because if you get an old resource that has a whole bunch of states set on it, like you'd end up doing this anyways a lot of the times. It compiles to C++. Oh, okay, I see. Yeah, so I mean this is kind of it. There's really not much. Action sequence is really just an array of actions, and an action has a function pointer to on start, for update, function pointer for is done, which yields a boolean, right? And again, you don't even need all of these. You only use them sometimes. Like I said, my main ones are immediate, do the thing, this action is done. Immediate, wait, start a timer, check if timer is done, do until, update, that's here, start something, do something else each update frame, check if condition is done. That's kind of it. I almost never use frame. Do the thing, next frame, don't start the next frame, the next action until next frame. It's like if I have a whole bunch of immediates, they'll all fire in one frame. If I have a whole bunch of frame, it'll be action, 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 once per frame. And these aren't all used all the time. Like an immediate doesn't use is done. Only this one does. Even wait could not have. We could have skipped wait and just used the do until as a convenience. This was useful enough to be a convenience method. So, yeah, lots of different ways to do it. Working with a priority queue, yes, you could. Yep. Yeah, you can prioritize which ones need to start first. Oh, I see. Yeah, no, I mean, once you have the basic structure, you can do all kinds of things like ending a sequence that's still going, starting one, setting up a delay before the next one starts, all kinds of stuff. Just the base loop is pretty straightforward. So, yeah. Where were we? Got a little time. So I need to click an envelope to plant seeds in a pot. Okay. But right now nothing's going to grow because there's no seed in the pot, right? Texture quad m_seed. We only need one. We got chocolate plants. CPP. For sun. My number of children has to increase, though. We need a sun, a cloud, and a seed for now. Init elements. Where is sun and cloud? Seed set texture to the same texture everything else has. It's all in the same thing. Seed. So it's all going to happen inside of. Wait a minute, let me look at my seeds in the graphic. I think they're not all the same size. Yellow, red, green. Oh, they are all the same size. Good. So we can actually save ourselves some work. Init elements, seed. So we get the seed width, height, width, height, width, height. Seed, set rectangle, oops, that's fine. Rectangle. Seed height, there we go. And we'll just use, what, seed red, because it's easy to type. We'll come back around to that shortly. Red. Okay. Yeah, this is cool though. No, yeah, once you have the basic scheduler action sequence thing going, you can add a lot of, like we have play sound, we got start sound, it just starts it and then it stops tracking the sound. Let the scheduler do that, or it can wait until the sound is done, or the animations. I can start an animation or I can wait for the animation to be done to move on, all sorts of things. You can add all the abstractions you want to your own scheduler and action sequence. Let me think. So that's the seed. Render. The seed has to render after pot, but before the envelope. And the seed will start off disabled. Seed enabled equals false. Okay. Envelope. Oh, interesting. We actually want to set envelope because we're going to rotate it. Actually, nah, it'll be fine. We'll leave it where it is. Ooh, is that true? Envelope. Set center and width over 2 and height over 2. And then we move the envelope. Nice envelope height over 2. So I guess the scheduler is sort of my way to deal with not having coroutines. Although I'm not even sure a coroutine would be any better because it's kind of the same idea. It wraps up a whole bunch of state and says, "You keep track of this life cycle, and I don't want to know anything about it." But in Unity, a lot of this would be done with like a coroutine. Okay, so the seed isn't actually doing anything yet. Right-click the envelope. Okay. All right. Set bounds. I kind of don't care about any of that. Plant. Alright, so the state's going to do that. And this is going to get a little complicated. So envelope, move over pop one. Envelope, rotate 180. Drop seed. Envelope, rotate 180. Move over pot 2. Move over pot 3. So we need basically 12 actions to get this all done. Oh, and then return. Let's see here. Fling envelope off screen. Disable envelope. Fling unused envelopes off screen. Disable unused envelopes. I think that's my sequence. This can be started and fired off and ignored by the main thing. So why don't we start with that? So let's just do 2. Or we could fade them out. Fade. Fade unused envelopes out and disable them. Fade envelope out. Okay. All right, you're gonna head out. It was fun talking though. Yep, I'm gonna wrap up my stream soon myself, but you have a wonderful evening and we'll see you tomorrow. Okay, so our sequence, we need an animation. Animation. Set duration 0.5. Animation set range. Yeah, we're gonna have to do some interesting things here. That's fine. From 255, 255, 255. Oh, not 255. Okay, we gotta get the color. Nope, we're just gonna get the alpha. Texture quad. I think it has a set alpha. Nope. Okay. Not sure, not sure. Let's see here. Let's go from 255 to 0. We need this, and we need the index. So we need a float alpha. Now we're going to say for index equals 0, index less than number of envelopes plus index. If index envelope index. Envelope index is not equal to the index we're trying to do. There we go. Then colored C equals envelopes sub E index dot color C dot set alpha. Oh, we'll do it that way. 1 to 0 set alpha f of alpha and just envelopes sub E index dot set color to our new color. That's basically that. Oops, let's see here. Set and play animation. 0 anim sequence set. Immediately after that animation is complete, we take this and index. Envelopes sub E index dot label equals false. Unused envelopes. Active envelope. So it's going to be 1, 2, 3, 4. It's going to be 12, 14 actions long. We're mostly going to ignore that for now. Oh, and then this thing. So sequence, let's see here. Action index equals 0. Immediate action index 2. Do these two things and we could also do these pretty quickly. Let's see what happens here. Index is not captured. Okay. Oh. Not sure how far we're going to get in today, but the planting of the seeds and then the growing states. So we may have spent too much time talking today to get quite as far as I wanted, but that's okay. Okay, so if we right click this one, the other two fade out. Okay. So pot 1. We already have a way, sort of, to get that. And we're doing that in rain. Where's my Y? Somewhere I find a good Y. So we get our plot width, we get our plot height, which we need. We get that. We do not need this set now. We're trying to center over the pots. Pot 1 X plus our pot width. Pot 3 X. Let me think. X is this thing moved over one pot and one space. That's fine. I think that's it. Okay. Give me an animation. Set duration. It'll be 1 second. Set easing method. Easing method. Log in. Out. Yes, it's fine. Animation. Set range. Where's our Y? I got a Y somewhere. That's the Y. Okay. Set range from. I guess I need the actual envelope, don't I? Texture quad. Underscore envelopes plus index. There we go. Envelope. Rectangle X. Envelope. Rectangle Y. 2. Pot 1 X. Y. Oops. Method of application, capture envelope, just say envelope point to X and Y. Sequence point to set. Play animation. Where's my animation index? Action index? Action index right there. Okay, now it's this time it's pot 2. So from pot 1x y to pot 2x y. Pot 2 to pot 3. Fade envelope. We got an animation for that already, right? Here. envelope. Fade it out and deactivate it. Action index. Okay, let's just see how that looks. Because we're close. Oh, yeah. Move to X. Float X, float Y. Okay, if we declare this, copy pasted it. Index is not captured. I don't think we need to here. This I think is the last one. Okay. So our little guy should fly up, float up, and there shouldn't be a pause, but it will speed up and slow down as it moves from place to place. So we'll just see what happens. Okay, we're going to take blue and fade. Okay. That worked shockingly well, actually. Except we're going to move faster to the other pots. The move from where the envelopes are over the pot is much further. So, all right, rotate 180 degrees. Minus 180. Oh, not 180. Math. Dead to rad. Thank you. Float angle. Rotate to this angle. I'm going to rotate from this to this. That's basically it, right? These durations on the rotations are ridiculous. Rotate to. Quick little rotation. Maybe we don't go the full 180. Be nice if the seed looked like it. Nah, the full 180 is fine. Okay, let's take the yellow one. Oop, oop. Not quite. Not quite what I was looking for. From 0 to the rotation, from rotation to 0. Okay, so I should clean up the rotations a bit. Oh, we don't have to do the rotation back after the last seed, do we? Okay. Let's take the blue one. Flip, rotate, flip, rotate, flip, rotate. Drop the seed. Do I have time? I don't really have time to do that yet. We might need actually 3 seeds. And that would be fine. One thing that needs to happen is to set plant state. We don't need to do this at all. Once we drop the last seed, we can just fade out and go away. Drop the seed and a small weight, maybe. Not a long weight, like drop seed here. 0. Let's see here. Action index. 2.25, 125. Not very long. We just want to wait long enough for the seed to come out of the envelope, which we'll get to tomorrow. And then the plant states. Means we did pretty good today. Not quite where I want to be, but almost. Okay, let's pick this envelope. Flip, flip, flip. Okay, I think we're gonna have to call it there. Journal. Planting animation sequence started. Need to drop seeds and need plant state. That's it. We're going to call it there. Thanks for dropping in. Thanks for watching. You have a wonderful evening. I'm going to see you tomorrow. Bye-bye.